Today I want to talk about two seemingly unrelated topics, but definitely interesting, is bird poop and U.S. foreign policy. So the U.S. foreign policy part of the equation, we can actually just start with it. So down here is a map of the Pacific Ocean, and what we have here is it's a U.S. protected area. It's called the Pacific Remote Islands Marine National Monument, and this is the largest protected area in the world. It's 490,000 square miles. Again, this is under U.S. protection. And to see the relationship between bird poop and U.S. foreign policy, we'll begin with this protected area. But the next step we'll have to look at is the fertilizer, the wonderful world of fertilizers. So when I'm talking about fertilizer, I'm kind of referring more to synthetic fertilizers, so man-made fertilizers, and the role it played in supporting the growth of the global population from about 1 billion people in 1900 to roughly 7 billion today. So here's 1900, here's 5000 BC, and then here's today, 2014. So if you look at the timeline here, the global population grew at a very low rate for thousands of years. We reached about 1 billion people in 1900, and then it exploded over the past 114 or so years to 7 billion. And this enormous population explosion was facilitated, as alluded to earlier, by the use of fertilizer. So fertilizer are nutrients that help plants and crops grow. And it's believed that a synthetic fertilizer has increased the productivity of agricultural crops by up to 4 times. Now, when I say synthetic fertilizer, I want to compare it against or contrast it against organic fertilizer, which are not man-made in the traditional sense. Organic fertilizer are largely plant waste, such as peat, and animal waste, such as manure. Now, to support this type of growth we have here, this explosive growth from 1 billion to 7 billion people, there simply isn't enough organic fertilizer in the world. So to supplement this, or essentially to be the majority of the fertilizer we use for agriculture, plants and crops, we have to create synthetic fertilizers. Now, synthetic fertilizers, most important ones are down here, is nitrogen, phosphate, and potassium, so NPK. Anybody that's ever bought soil will know these letters very well. These are the chemical letters for these 3 compounds, or these 3 elements, sorry. But basically, a synthetic fertilizer has allowed us, this is a picture of the globe, to only use 15% of the available land in the world for agriculture, opposed to 50% if we had less productive fields. So not only is a fertilizer facilitating this explosive growth we see in the top right here, it's also saving us quite a bit of land by increasing the productivity. Now, I want to touch a little bit more on these synthetic fertilizers. And so I want to focus actually on nitrogen, because while all 3 of these, N, P, and K, are available as deposits to be mined, phosphate and potassium deposits are much larger than nitrogen. The largest source of nitrogen actually in the world is in the air. And I'm going to point down here, and this here is the makeup of air, the chemical elements. Air is 78% nitrogen, 21% oxygen, which obviously we need to breathe, and 1% other. So it seems like there's an abundant source of nitrogen to be used as a fertilizer for crops and plants. But unfortunately, this nitrogen is not what the term is bioavailable. So plants cannot actually use them for nutrition. So that's bioavailable. So the form that plants need nitrogen in is actually called ammonia. And the chemical formula for ammonia is right here, NH3. It's 1 part N and 3 parts H. So 1 part nitrogen, 3 parts hydrogen. And now the process the chemical process which is used to create large amounts of ammonia was actually discovered at the turn of the 20th century. By 2 German chemists. They're credited primarily with the commercialization of ammonia production. The first one I just circled here on the left is Fritz Haber, and the one on the right here is Haber-Bosch. So basically, they figured out how to get this nitrogen from the air into this more bioavailable form called ammonia. And the process is called fixing. So you fix nitrogen to make it bioavailable for plants. So the problem with nitrogen in the air is what in chemistry is known as a triple bond. So as you see here, this is a nitrogen molecule, and the three red lines are the bond. Triple bonds make it very difficult or impossible for plants to use it as a nutrient. So the way that the Haber and Bosch, they created the Haber-Bosch process, figured out how to create ammonia from nitrogen was by essentially smashing nitrogen and hydrogen molecules together. And so this is the formula. And as you can see here, by combining nitrogen and hydrogen, we got ourselves ammonia. Sorry, 2 molecules or whatever of ammonia. And basically, the resource that we use for nitrogen is, sure enough, the air, so like an airdrop. And the resource we use to get hydrogen is methane, primarily methane, so natural gas. In fact, the production of ammonia here, which is an important fertilizer for plants and crops, synthetic nitrogen, so the fertilizer ammonia is methane, and basically 2 to 3% of the world's complete energy use, because methane is a natural gas or a form of energy, is consumed in this ammonia process. And basically the process was commercialized in 1913, which I've written here. And this picture is a picture of a reactor where these nitrogen and hydrogen would combine to create these ammonia molecules, or compounds, sorry. So this brings us to birds and bird droppings and how it relates to U.S. foreign policy. We're getting one step closer. So bird droppings from seagulls specifically is known as guano. And it was actually referred to as a white gold in the 1800s. So if synthetic nitrogen was found around the turn of the 20th century, in the 1800s, the main source for nitrogen was guano, this was so-called white gold. In fact, in around 1850, a kilogram of gold was worth $600, whereas a kilogram of, these are bird droppings, was worth $167. So as you can see, guano was very valuable because it was known as this very important synthetic fertilizer, or compound as a fertilizer. Actually, it wasn't synthetic. It was, I guess this would be organic. So the largest deposits of guano here, this source of nitrogen in the 1800s, was off the islands of Peru. And as we circled earlier, in the middle of the Pacific. So these green dots here, these are Peruvian islands off just the coast of Peru. And basically what happens in these waters, it's known as an upswell, is these are nutrient-rich waters which attract a lot of wild or marine life. So here's a fish. And obviously marine life is going to attract birds. And when birds eat fish, we get lots of these, bird poop. And the picture I have here on the left is exactly that situation. This is an island that humans have built some type of platform to mine all this guano, this white gold, this bird poop. You can't see the seagulls here, but they kind of dot everywhere, and this is all their work. This is just a massive poop. So this white gold was extremely valuable, and a lot of it was found off the shores of Peru. The competition for nitrogen was fierce. Spain actually fought a combination of Peru, Bolivia, and Chile in the 1860s to gain access to some of these guano deposits. And then Chile actually fought with Peru and Bolivia to gain access to rich nitrogen deposits, which actually weren't guano, but again, nitrogen was the key here. So now we can get ourselves a little bit closer to how this relates to U.S. foreign policy and bird poop. So, as mentioned, Peru, which is basically in this general vicinity, the islands off Peru provided a lot of the destinations for bird poop, a lot of bird poop targets. Another very bird poop guano heavy area was in the Central Pacific, right here, where my old blobby squiggly thing is. And the United States in 1856, basically recognizing how important nitrogen was as a resource from bird poop, they passed something known as the Guano Islands Act of 1856. So Guano Island, and it basically allowed any citizen, sorry this is not being read well, Guano Island Act, any citizen that could claim unclaimed islands in the Pacific. You just hop about, you find an island, there's a bunch of bird poop on it, you claim it if no other country claims to it. Then the United States the government will basically protect it and mine the guano off of it. And over the course of, of 50, 60 years, the Guano Island Act resulted in about 100 islands and atolls being brought into U.S. jurisdiction. And today, there are only about 9 of those still in existence or still under U.S. jurisdiction. And that essentially has given the United States, so the green here are some of those islands, the ability to create this massive protected area. Because by the UN law, with any island that you have the right to protect it from 200 miles outwards. And essentially, this black blob I've created are from these islands that were claimed under the U.S. Guano Act and allowed the United States to protect this entire area. So yeah, that is basically the story of how bird poop and U.S. foreign policy are related.